Hey pals, welcome back to a new video. Today, I wanted to talk about shader graph. Shader graph is a tool inside of Unity that allows you to basically, with visual scripting, create your own shaders. Shaders can be a little tricky for game developers, especially ones who are starting out, because they require a different programming language to C# to actually create. It's either HLSL or GLSL. But using shader graph, you can get some pretty effective visual effects on your sprites and on your models without doing too much setup. So I want to show you this tool today and give you some examples of how you can use it to up the level of visual presentation in your game. Okay, let's get straight into it. Here we have kind of like a mock scene from my game. It's using assets from my game. It's not actually in engine. And you can see here that, it's looking nice. I'm happy with the way it looks, but I'm not 100% happy with the way some of these assets combine on the screen. For example, Armin's arms here get kind of cut off a little bit by the colors. Like there's such little distance between them that they're almost invisible. And if we were to change the scene into like a more nighttime scene, I like this tile set, but the contrast between the tile set at the front and the background is way too high. Like I'd want to bring this down. So there are things that we can do using shaders to change both of these things without having to redraw our assets or duplicate our assets with different kind of export settings, changing the brightness or whatever. So basically, all you need to do is, if you've got the package in Unity, which I believe is now currently standard, and you have the universal render pipeline kind of set up, you should be able to go create shader, universal render pipeline, and then in this case, we're going to use a sprite unlit shader graph. You can use lit as well. The lit ones will take on brightness changes from lights around them. And we're going to call this first shader, just to play around. So when you click on this, essentially this will take you to an editor, and that editor is shader graph. Shader graph has a few different kind of properties that you should be aware of. The first is the blackboard here on the left. This is the set of inputs to the shader asset. There are some defaults here that you need to expose. Those will become basically nodes that you can then work with. Then you have the outputs. Whatever you plug into these is going to be what's shown. You have a visual preview of your image, and you have the inspector for whatever node you're currently selecting. What we're going to do is just sort of get something going. So the first thing you want to do is have your texture 2D. Okay, this can be called whatever you want. And the node setting for this is what's really important. So shaders have what's called references. This is like a variable name. And inside of Unity, in our inspector, the properties on things like a sprite renderer will refer to those shader properties. So for example, sprite is the main text property, and color is the vertex color. So here, when we click on our texture 2D, this reference, if we write underscore capital M main, capital T text, that will basically link to whatever it is you've plugged in there. It won't show up in the preview, but when the shader is actually active and on that sprite, whatever's in this slot here in the sprite renderer, that's what will show up in this property here. So we can take our texture 2D and we can drag out from this little node, and we can say sample texture 2D. Okay. What this does is it creates a node that previews this texture. The way these nodes work is they take inputs and they have outputs. Everything out from here is a color. And in fact, everything to the right of a node that is a sample texture 2D node only affects the color. For example, if I take this output here, there are 5 channels here. One of them is the combined red, green, blue alpha. It's the entire color of what's being sampled. And then there's also just each of the channels separated out. So this is like a vector 4. It's like a color variable. And this is just a bunch of, floats for the value of each of those channels. So the amount of red, green, blue, and the amount of alpha. We can preview this by dragging out and just typing add. And add is just an addition, but if you add nothing, you'll get the preview. You can see that the alpha here is 0 or black, where there's transparency, and white or 1, where there is opacity. Here, we don't see that alpha just because of the way that it samples it in the preview for the sample texture 2D, but we know that if we sample this and we check it out here, we can see that this is actually what's coming through. So the way that this works is every single node in this kind of like fragment side of the shader, and there's two halves of a shader, a vertex and a fragment function. Everything that's going to lead into this base color or this alpha, anything that goes over here, every node along the way deals explicitly with adding, multiplying, and transforming colors. It can't move things left and right. It can't do anything to do with changing what the output of this is. And the output of this is basically just, you know, a series of pixels. We can change the color of the pixels. We can change the brightness, the opacity, but we can't change their positions. All of that has to happen before this in the UV. So if we want to turn this into a functional shader, all we have to do is get something into this output. I can take this output here, throw it over here, and immediately we can see something, but there's no color information coming in, so we just know that there's some transparency. And then we can take our RGBA, pass it out, and that gives us the most basic kind of shader you can have. By default, this will be sphere, which looks kind of awkward. So you can right click it and press quad, and that will give you a rectangle basically to place the shader on. So this is your first shader. This will essentially just take your texture and it will output the image onto the material uninterrupted. So we can save that, we can minimize it again. And if we apply this shader to our sprite, nothing will look different, which is success. So the way to get a shader onto a sprite is to create a material. You'll notice if we go to our character sprite, there's no shader property, but there's a material property. The way to create a material is we can just create that as an asset, create material. Okay, so that'll give you this. To apply the shader to the material, you just drag it on. There we go. And then we can just drag the material into the material property in the inspector. Now we have something we can work with. If we go to our shader and we make any kind of changes, those changes when we save will be used to update what we see in our output here. We don't need to keep this in a window here, but just to prove that it works. What I want to do is instead of outputting the color of a texture, let's just create a color node, basic color, and pick a random color and just pass that in instead. So we're just saying take red, pass it in, so it's just full red, and then clip the alpha to what the sprite's alpha is. So that'll give us a red character. If we minimize this, there it is. The shader compiles and it's red. So if you can do that, you know you've got a functional shader that you've created in ShaderGraph. Congratulations. Okay, so from here, you can imagine we can start doing some maths, right? We could take our RGBA, we can add to it. We can take the output of this and plug that in. And instead of adding nothing, maybe we could add the color to this. And so you can see that all of the red got applied over Armin's colors and they all shifted in the direction of white. So when you add things in shader space, right, all of the colors have a value between 0 and 1. When you add them, they approach 1 because anything plus anything, unless it's a negative number, goes up, right, towards 1. So colors will get brighter when you add them. Another thing is we could multiply. Okay, let's multiply instead. What do you think will happen when we multiply? Usually when we think of multiplying, we think of things becoming bigger, but they actually get darker in shader space because everything in shader space that's not bright white is less than 1. And if you multiply something by less than 1, you're actually getting smaller. Like 0.5 times 0.5 is 0.25. It's not 1. And so when you multiply things, it gets darker. Now, what do you think will happen if we divide? It gets brighter, but it gets brighter in the opposite direction of the color that we divided by. So you could just try to, play around with things and see what you get. It's a little unintuitive at start, but once you play around enough, you'll find that there are a series of things that you can think about and ways of understanding colors that are intuitive. It does figure itself out eventually and you become more comfortable with it. It's just a matter of practice. So we've been talking about colors so far. The UV is the set of coordinates that the art kind of lives on. Now, if we go back just for a second to the scene, you can see here there's a rectangle. If I press T, this is the actual like sprite itself, right? This is the texture. A shader cannot draw outside of this texture, but you can do some maths to this to shift or, you know, scale or transform the sprite within the context of this bounding box. We can take a default node called UV. So you right click, create node UV, and this represents that space. Okay, it represents like the default position space of your sprite. And if you pass this in here, it's actually the default value. But you can do some maths to this as well. We can add to this UV to do things like shifting. So instead of rendering, you know, right where the pivot is, we're rendering it off to the side. So knowing that you can make operations happen to the coordinate space of the image, and knowing that you can do operations over the color space of the image, that kind of opens up the possibilities for literally anything that you've seen in a video game with shaders. And a lot of that stuff, if it's animated, you know, will use time, right, to as part of the operation. So, you know, maybe a color increasing over time, or a noise space being sampled through time. So you can have noise as a gradient, and you can sample the color via noise over time. You know, for example, we could say take a UV, and we can add to that UV. So we're translating by time, but let's just say on the x-axis. So we could say vector 2, and just on the x-axis we want to have a number that's time on the x-axis and 0 on the y-axis, and add that. And then we could pass that in to the UV, and we can now scroll through the noise space. So the noise space is being offset on the x-axis by time. Okay, this seems a little crazy if you've never seen this before, and you might think, well, what do I do with that? So if we want like a really crazy thing we could do, we could just pass that directly into the sample for our character. Maybe that's a little too crazy. We don't want to blow your mind too much. We've entered the almond verse here with the with the sampler. You could divide this or multiply by a very small number, like 0.1, and then you could add this to the original UV so that we got something that still looks like our character. And then you can have it sort of like look like water, right? We could increase the scale of this, and that's how you do, you know, puddles and waves. So these are really common techniques that get used in games all the time to do things like procedural, natural effects. Now, I've shown you a lot of cool stuff, but I want to show you something more practical. So we started at the very beginning with our character in the scene, and I want to try to make the character stand out a little bit more. So let's create an outline shader for our character. Outline shaders are a little much, but I believe in you. I think you're going to be able to handle it. So what is an outline? Okay, let's come back to a sprite for a second and just think about what an outline does. We trace along the edges of a sprite, and anywhere that we see an edge, we basically add a pixel. And the way that this works inside of the actual sprite tool, if you press Shift O, it will give you these directions, right? Above, below, left, and right. And by default, it's just those. But if you go, you know, in the corners as well, it will kind of make it a little more square. But you can see if we take some of these away, let's just this one, what are we doing? We're actually just outlining to the right of the character. We're taking the entire sprite and we're shifting it, almost like shifting a black version of the sprite 1 pixel to the right and putting it behind the character, right? And then we could take that and duplicate it and put it on the left side of the character, and above the character and below the character. That is an outline. It's a darker version behind the character, or a colored, single color version of what we're seeing on the edge here, and putting it behind the character. That's essentially how you do outlining in games. So we're going to create a shader that performs that. So how might we try to create a colored version of the character that's behind the character? Well, we've sampled the character once, but there's no reason why we can't sample it again. So let's just create another sample. And let's, instead of using the default UV here, let's shift it. So we can add to this UV some distance. Okay, and that moves it across. And if we could get it right, like 0.01, we might be moving over exactly 1 pixel in a direction. Now, rather than just take, you know, the sprite, let's just take the alpha of the sprite. So let's take this and let's add it to the default alpha. Okay, it's going to look a little bit wider. So you can see that the amount that we've shifted by is not perfect, right? We haven't moved by 1 pixel because there's kind of like a bit of a step in the middle, like a little short gap. So we need to know how much to move this by. Now this is in kind of like UV space. And in UV space, 1 is the entire width of this thing. And 0.01 would be 1/100th of the thing. So if this was a 100 by 100 pixel, 0.01 would be correct, but it's not correct. I know that the sprite is 64 by 64. So if I did 1 divided by 64 and put that in the X offset here, that would be correct. But there's an easy way to do this, which is, it's called texel size. The texel size is the size of our texture. Now, I think in actual shader terms, it's 1 divided by the amount of pixels. But in this case, the output of this node is actually just the amount of pixels that we've got. So to make this work, what we want to do is we want to create a node that is a vector 4, and that's going to be plugged into this. And we're only going to change the X amount, right? So what we need to do is take this and also turn this into a vector. Width to go into the X, height to go into the Y. This is just allowing us to do some maths with both of these properties at once. And I want to divide 1 into this number. Okay, so we're going to create another node, which is a vector 2 as well. We're going to plug this into the top half of this. And this now, if we put a pixel into this or a pixel value, that will offset it by that much. If I press 1, that will then, sorry, don't need that. So if we go directly into this, we can then move this by a number of pixels and we can see it shifting. So this 1 pixel, 2 pixels, 3 pixels, and you can see it here, right? Then the size of this is perfect. This is the core of our little outline here. Now, unfortunately, it's not very pretty, but in order to make this work in 4 directions, you have to copy it 4 times. What we want is to create essentially a function out of just this part here. I'm going to take all of this that we've done so far, and I'm going to convert it to a subgraph. And we're going to call this outline component, offset component. So what that's done is it's basically taken that code that we selected and it's given it its own shader graph editor. It's created an asset and we're now inspecting that asset. This is sort of like a function, right, in normal C# scripting. It's a piece of functionality that we can then give some parameters and turn into something more modular and then reuse elsewhere. What this needs is a property, right? Because we want to have the 4 different components being up, down, left, and right. So we need here maybe a vector 2, and we're going to call this offset. And then we're going to plug this vector 2 offset replacing this. And that's it basically. We don't really need to do the add. We could just pass this out there. And this gives us a nice white alpha offset. Okay, so this one we could say 1, and then we can make 4 of these. And if you like, you can collapse them too. That makes it a little bit easier. Okay, so we're going to have 1 and then -1 and then 1 on the y-axis and then -1 on the y-axis. Now, if we add all of these together, now we've got this thing, right? Which is basically a flattened version of the whole thing. Now, unfortunately, they've been turned into spheres when we do this. So we won't be able to see the output very nicely offsetting in an easy way, but you can see here, we can see it on the sphere rotating. So we know that it works. The best thing we can do, I guess, at this point is pass this into the output to preview it properly. And it works. Armin's a little bit chunkier now. So that's not quite our outline just yet. Let's delete this here so we have like a clear understanding of what our thing is actually doing. If we pass the same value into the color and the alpha, it looks like it's all white, but it's not really all white because values greater than 1 don't appear any whiter than full white, but those values are still there. And because we added a bunch of numbers together, the parts where they overlap the most, those parts will be definitely much, much greater than 1. And the parts where they overlap the least, those parts will be exactly 1. So right in the center, there's like an almond-shaped thing, which has got a value of probably like 4. And then all around the outsides, there's a value of 1. We could probably test that actually. Let's take this and we could subtract from this 4. So basically this is the part where there is full overlap, where all of the outlines overlap with the original. But there's something here that I don't like either. And that is that you can see it's not actually a perfect silhouette of Armin. It's actually based on the brightness of the elements inside of that. So I'm actually going to go back to our offset and I'm going to do what's called a step function to essentially take all of the values that are less than 1 and bump them up to 1 if they're greater than some value. That's what step does. You can see here it returns 1, so it makes it white if the value of the input in is greater than or equal to the value of input edge. Okay, so the edge value in this case is, let's make it like 0.01. So any pixels that are brighter than 0.01, they're just going to be considered white. Which means we know that because our alpha is completely 0 outside of the silhouette, what comes out of here is exactly going to be white. And if we close this and go back here, let me save it. Do we get anything different? It is different actually. We had different parts of the feet visible before. And we can change this value. You can see here in this subtraction, we're actually getting different layers visible depending on the subtraction value. But if we don't want that to happen, if we just want the output of this to be just like a solid color, we can take this and we can clamp it, right, between 0 and 1. So anything that's greater than 1 will be considered exactly 1, and anything that's less than 0 will be considered exactly 0. So this is effectively our alpha representation of the outline for the character. The only thing that we need to do now is isolate the original from this so that we can then put Armin inside of it. We want to kind of like subtract the original alpha first so that we get this like hollow version of this thing here. So what do we want to take away first from this? Well, we want to take this away from this. We want to subtract this. And this gives us, lo and behold, our outline. Now in this case, I have got an issue with my sprite where I've got the character drawn directly on the bottom. So nothing can get drawn outside of the texture. Because Armin here is outside of it, I have to bring him up a little bit if I wanted to make that work. We're just going to ignore that for now. I got to fix that in my game. But what have we done? We've gotten all of those additions, right? Left, right, up, down. We've added them all together. We've flattened them down so that they're all white, one color. And we've subtracted the original silhouette from that. So all of these are now 0. All of these pixels where Armin's silhouette really was is 0. And only the stuff that we added by shifting left, right, up, down remains. And that's an outline. It's perfect. But we want to put Armin inside of that. So let's just add to this our actual colors for Armin. So we can just add this to that with this as the alpha. And there you have it. So the clamped, fully outlined version that had the solid inside center, which was this one here, that can be our alpha because we still want Armin to be fully opaque inside. And so that's fine there. And then we're just combining for the color section, Armin's original sprite and the outline that has no center. So maybe it would be a bit better here if we just sort of like talk about this one more time, and I'll break it down and annotate it as well. So let's just break down what we did. So first, what do? We sample the original sprite, and then we offset the silhouette in all 4 directions. And then we added them together, and then we clamped them and that flattened them down. So we have this big fat flat version that's all white. And then we subtracted the original silhouette from that so that we just get the hollow outline. And then we add that back to the original here. And that gives us our outline. So if we want to take this output, which is the white outline, and before we add it, we want to color it, you could just multiply any white color by a color and it'll create that color. Okay, because you're multiplying something by 1. So let's just add a color as a property. Here it is, pass this in, and then multiply, plug it in here. And then we need to give it an actual value here first. So let's give it a lovely green if we want. The outline looks really good, but we've got a little bit of leaking going on, right? There's something happening around the outsides where it's a bit brighter near the brighter parts of his arm and a bit more blue near the blue parts. So we've got some of the color that's kind of like making its way into our outline when we do this addition. And the way to fix that is to take the alpha and invert it. So 1 minus gives you the opposite of that number. So 1 minus 0.25 gives you 0.75. Okay, so we subtract the inverted alpha from the original color. That makes all of the colors that were kind of like in a halo around Armin here, in these spaces here, makes them completely black. And then we clamp that number between 0 and 1. So we went, some of those numbers are now negative because we subtracted all of this white, which is 1, from something which was invisible but still there. So all of this color here, which gets interpreted here by Unity, even though it's empty, maybe it's the way that it's encoded through a sprite, who knows. All of that color, we just subtract, right? All of this white gets taken away, cut out from this. Now we know there's absolutely nothing here, but that nothing is in the negative, right? There are some negative colors in here that are darker than black. So to fix that, we clamp the whole thing between 0 and 1. So now everything we see here is no brighter than white and no darker than black. In fact, the black is 0 and the white, there's no white, but if it would be exactly 1. Then we can pass that in here and immediately it fixes it. So the green is pure green. It's not being added to anything. This, I'll just call this like sanitize color. And that's just to, get rid of any kind of like leaking colors that were outside of that. And that's it. That's your outline shader. So this is, kind of complicated. There's quite a few operations that we had to do to get here, but hopefully it's starting to come together as something that makes sense. What's cool about this is that if we save it and we go back to our scene, we can see the result is here. And it means that we can go to this shader and we can change this color property to whatever we want. And once you've got this outline, you could do it to anything, right? I could outline the terrain if I want. We could take that material and we could give it something that's a little more earthy, We could even calculate this procedurally so that we know based on, the average colors of the scene, we could change it to be a bit more, appropriate. We've got options now, and shaders give you that power. So this, I'm sure, felt like a lot. And if you were able to follow along, I really appreciate your patience. It is definitely something that's a little more programming than it is art, but in a way it's kind of cool that shaders have this interesting intersection between the two. And once you get really comfortable making your own shaders, you can start looking at games or thinking about effects that you want to see and very easily combining them together and putting them together here in ShaderGraph to create some really interesting, cool effects for your game. I've got stuff where I wipe upwards from the bottom to the top of the character over time, reflection shaders that kind of shimmer and flash when you walk past them. I've got all kinds of stuff. So hopefully, if you're interested in this kind of content, I can make more shader examples and make videos out of those. Let me know what kind of stuff you want to see, and I'll see if I can make it here in ShaderGraph and show you how to do it. And I'll catch you in the next one. Hey pal, thanks for watching, and thanks most especially to the patrons and Twitch subs who support this channel and my game dev project Insignia. To find out more, click the links in the description below. And if you like this video, tell YouTube by clicking the like button, and then YouTube will tell me, and then I'll make more videos. That's nice. Thanks again, and until next time.